So let's practice naming ionic compounds, not just naming the ions individually. So if you're naming ionic compounds, you are going to name the cation first. You're going to see that the cations are written to the left. Cations are usually metals, but they can be polyatomic ions. So when you're naming the cation, you name the metal with or without the Roman numeral, or you just name the polyatomic ion. When you're naming the anion, this goes with the IDE ending if it's monatomic. If it's a polyatomic ion, you just name it. So let's start with this one. So we look at it, we say, hey, okay, this is a metal, this is a non-metal, so I'm going to name it like an ionic compound. I'm going to name the cation, but I gotta determine, should I put a Roman numeral for this? And for magnesium, you find magnesium on the periodic table, say, oh, it's a group 2. That means it's always a +2 charge, so I don't need a Roman numeral. So you just name it. Name the cation. And then next is the anion, and this is monatomic, right? It's only fluorine, it's not a polyatomic ion. This gets a IDE, the IDE ending. Right, so you have magnesium fluoride. That's it. Next one, we've got FeBr2, so we see the cation. The cation is iron in this case. And we find iron on the periodic table. We see it's group 8. It's a transition metal, and it's not part of that triangle, so it does form more than one charge. So now we've got to figure out what the charge is. We figure out the charge on iron by looking at the anion, or anions, that it's with. This one's with bromide. So we have to look at the periodic table to figure out the charge of bromide. We find bromide is element 35. See that it's in group 17. And group 17, we predict a -1 charge. Well, we predict a -1 charge, and there's 2 of them. And that's a total. It's a total of negative, right? If we add that up, that's -2. And there's only one ion. So that ion has to have a charge that is going to make the total charge be 0. So the ion is going to have to be +2 all by itself. So this is going to be called iron 2 bromide. So this was a metal. It forms more than one charge. Since we have a formula, we figure out the charge it must have based on the ion that it's with. So that's that. Next one, we've got aluminum carbonate. Well, we've got this, Al2CO3 3. So first we look at the cation, right? On the left, aluminum, this is the metal. We find aluminum, aluminum is in that triangle I told you about. Aluminum only forms a +3 charge, so we just write it. The anion that it's with is a polyatomic anion. CO3, this is a very common anion, and you should just know the name. If you're looking it up at first, that's not so bad, but memorize them as soon as possible. And that is, CO3 is carbonate. Right, so this compound is now called aluminum carbonate. Next one is nickel. We have Ni, nickel, and we have another polyatomic ion. First we name the cation. We find nickel on the periodic table. It's in group 10, and it does form more than one charge. So nickel, since it forms more than one charge, we need to write the Roman numeral to say what the charge is. So we look at our anion. And the anion, PO4, we know that's called phosphate, if you look it up, and its charge is -3. So and there's only one, so that's kind of nice. It makes this problem pretty easy. There's one phosphate, and each one is -3. The only one is -3. So that means nickel must be +3. So we're going to name this nickel 3 phosphate. So the name of the cation is nickel 3, and the name of the anion is phosphate. All right, we keep going, and we notice, oh, we've got one. Nitrogen's a nonmetal, hydrogen's a nonmetal, and oxygen's a nonmetal. So this is one of those cases where you don't have a metal as the cation, you have a polyatomic ion. So NH4, we just name it. It's a polyatomic ion, you just write the name. And NH4 is ammonium. And then the anion is oxygen, which changes to oxide. As you're looking at these, you might work ahead and see if you can name some of these before I do. So we've got Pb, SO42. Pb, I hope you've heard, that's the symbol for lead. And we find lead on the periodic table. Lead is in group 14, which I did say was ±4, but lead's a metal, so we're below this line. Lead does form more than one charge. So for metals, if it's not group 1, and it's not group 2, and it's not in the triangle, we need a Roman numeral. Okay, so even on this section of the periodic table, we need a Roman numeral unless it's one of those 18 metals. So lead, we need a Roman numeral. Sulfate. Sulfate is the anion. Well, since I know the anion, I could write that right now. I know this is going to end in sulfate. If I'm going to figure out the charge on the lead, I need to remember the charge of the sulfate. Sulfate is -2. I hope you remember. That's -2. And there's 2 of them. So that's a total of -4. And I have 1 lead ion to make this add up to 0. That's got to be +4. So 1 + 4 combined with 2 - 2's adds up to 0. So this compound must be called lead 4 sulfate. You might want to review Roman numerals, maybe write them in your notebook somewhere. That's IV, lead 4 sulfate. All right, last 3. We've got TiCl4. Ti is the element titanium. It's element 22. Find titanium on the periodic table. You see, that's a transition metal. It needs a Roman numeral. So we need to look to chloride. Chlorine is going to change to chloride. I can write that in now. It's going to end in chloride. And I use the charge I expect for chloride to figure out the charge on the titanium. Chloride, I find on the periodic table, it is in group 17. Group 17, I predict a -1 charge. So I'd write. Right, there's all those -1s. There's 4 of them. So it's -4. So, and there's only 1 titanium. So the titanium has to be +4. That's going to add up to 0. Titanium 4 chloride is the name for that compound. All right, next one. We got KOH. OH is a really common polyatomic ion, so remember the name of that. K is potassium. K is in group 1, only forms 1 charge. So I just write the name of the metal, potassium, and this is a polyatomic ion, so I just write the name. So KOH is called potassium hydroxide. Last one, we've got Ca and NO3 with a subscript 2. The Ca is calcium. Calcium's in group 2. You'll probably start to recognize that. Oh, calcium doesn't get a Roman numeral. calcium. And then NO3, hopefully that looks familiar very soon. That is called nitrate, a very common ion in chemistry textbooks. And so we just write, it's a polyatomic ion, we just write the name of it. So calcium nitrate. Alright, so this is just an introduction to naming ionic compounds. Next, we'll write the formulas from the names.